Hello and welcome to Autology, the weekly podcast that brings you the latest on automotive technology. This week's episode is called Megacasting on the Rise, Dreaming Big. And you're here with me, Pranav Divakar, Senior Associate at S&P Global Mobility. And joining us today are Paolo Martino, Director at S&P Global Mobility, along with Michael Tao, Principal Analyst in the Materials and Chassis domain, also at S&P Global Mobility. Hello to both of you, and thank you so much for joining this week's episode of Autology.
Thanks, Pranav. Thanks for joining, and thanks to everyone listening in.
Great.
Yeah, thank you very much. This is Michael Tao speaking. Welcome to join this episode. I'm honored to be here to be with you in this episode. Thank you.
Good to have you here. All right, so jumping right in. In this week's podcast, we'll be discussing one of the hottest topics in the manufacturing industry, the rise of megacasting. The first question that I have is for you, Paolo. Based on your market knowledge and experience in the field, why is megacasting becoming so important in the manufacturing world? Any specific drivers pushing this?
Yeah, thanks a lot, Pranav. So yeah, I think it's very important and hot topic at the moment. Before going specifically into the drivers, probably it's also good to set a little bit the scene also for the listeners who are not too familiar with megacastings, right? And just to give a little bit of a background there, right? So of course, megacasting is a relatively new term, right? I think it appeared first when the CEO of a casting company called Hydra said it in 2019, I think it was, right? And basically with this term, we are referring to a manufacturing process that involves the use of high pressure die casting, right? To manufacture extremely large body parts in a vehicle. And so we are talking about more than 100 kilos weight in terms of a part, right? And they do this in just one shot, right? Using some presses, right? So some machines that are called gigapress, right? So this is the meaning of megacasting, right? And of course, I mean this process is involves applying a much bigger force than a normal or a conventional press, and it involves a lot of pressure, but generally speaking, it's still a casting process, right? So traditionally speaking, historically, casting methodology, so manufacturing process, have been used to develop some other parts in the vehicle, like for example the engine blocks or other gearbox applications and so on and so forth, right? And also in the body structure, I would say, I think that the casting have been used relatively recently. Let's say I think in the last 20-25 years, we have been seeing the use of castings also in an aluminum casting, more specifically in the latest stage, let's say, in the latest part of the decades, let's say, when other manufacturers like Audi, for example, started adopting this this methodology and using aluminum casts to do their body for their vehicles, let's say, the aluminum body for their vehicles, let's say. So this is a little bit the history behind the megacasting, right? And of course, I'm sure that we will deep dive into more of that. In terms of the drivers, pushing for the adoption of this new manufacturing process. So for sure, one of the main driver is, as I was saying, the advancement, technologically speaking, of casting technologies, right? So of course we started creating cast parts that were smaller in the beginnings, right? But with the advancement of technologies and the creation of this also new tools, we have been able to see a lot of advancement also in the potential use of larger pieces, larger casting made at one shot, right? So for sure, it's something that is pushing the adoption of this new advanced methodology or manufacturing process. On the other side, I would say there is also the new materials, right? So in the sense that there is for sure always a quest for adopting new materials, lighter materials. We know the lightweighting run is still in place, right, for all OEMs, right? And so the adoption of more aluminum parts, let's say, and also other potential, of course, materials is also pushing for the adoption of more innovative techniques, right? And of course, specifically for aluminum and high grade of aluminum castings, of course, this has been pushing suppliers and also OEMs, I would say, to adopt a new and more efficient manufacturing process that would allow them to scale up their production volumes, right, and make sure that they could create some efficiency. So this is what I see as a kind of top two drivers for the adoption of this new manufacturing process.
Yeah, it's a super interesting concept for sure. And what's your take on this, Michael? Any other factors that you can think of that's accelerating the adoption of megacasting?
Yeah, Pranav, thanks. Actually, I cannot agree more on what Paulo just mentioned. And from my perspective, I would say it's indeed the combination of emerging demand for alternative body construction method and technological development, which are both driving growth in the megacasting market. We do know that conventional OEMs, like what just now Paula mentioned, Audi, Volkswagen, etc., have accumulated tons of know-how throughout their practicing decades to build multi-material, multi-gauge body shell designs, which involve forming a large number of separate parts with dissimilar material and adoption of robust joining method and proper quality check processes, which are somewhat, I would like to say, no way to be simply replicated by startup OEMs who were less exposed to the auto industry before. Because of this, we have seen that in these years, especially in China, but not only in China, that newer OEMs are pushing for innovative but easier method to make the car body, which is hoped to not only resolve quality issues associated with high volume manufacturing, but improve cost efficiency and reduce the overall lead time for new vehicle model to the market. Secondly, as again, Paulo just mentioned, casting itself is a technique which has been used to develop auto parts such as engine block, gearbox cover, etc. It has been proven a successful way to cut cost, save weight on these small auto parts. But what Tesla has already done and proved is that it is viable and durable to make large car body structure with megacasting or some press say gigacasting. Only if right ingredients are added into the base material and new advancement in the metallurgy is achieved. Therefore, it is not very quite hard to touch to reach that point. If I remember correctly, there is some number disclosed from news release that Tesla saves approximately 300 robots for its Model Y's body line compared with the one for Model 3. Cuts 30% up to 30% of energy consumption to make single piece of the sub-assembly of the rear underbody and achieved good weight savings on the final part. So all of this, I have to say, have already attract the attention in auto industry and ignite the market's passion to chase megacasting. That's my point. Thank you.
Right. Now, I'd like to go a little more in depth into the announcement that was made by the Tesla boss, Elon Musk, last year, where he stated that he dreams of creating the entire body structure of future cars with just one or at most two megacastings. Now, Paolo, what do you have to say about that? Do you think that it's really feasible?
Yeah, it's always nice to hear Musk, right? I mean, and I think it ties in well with the title of our episode today, right? I mean, dreaming big, right? And I think that Elon Musk is the definition of dreaming big, right? So yeah, I mean, let's, but at the same time, let's be realistic, right? In the sense that, of course, we have seen that there are enough evidence saying that on specific, let's say, vehicles or on specific, let's say, segments, the adoption of megacasting is real, let's say, and it could be scaled up, used vastly. That's something really that is coming and can well be adopted in a widespread kind of fashion, right? But at the same time, at least with the current state of the art, right? I would like to be realistic in the sense that, doing the whole car with just one casting or two casting, I don't think that we are quite there yet. Of course, I mean, being overly ambitious and dreaming big, I like that kind of attitude and approach, right? At the same time, I would like to, to be, to have my feet on the ground, right? At the same time, right? So I think that, yeah, there is some potential there. We need to also take into account things like financial feasibility, all of this. I mean, it's all good on paper, right? But to adopt this mega castings, it also requires some financial investment, especially upfront, right? Which is something that not everyone can do, and probably I'm sure that we will deep dive on that later on, right? But I think that it's very important to stay on the ground and say, yes, this is the long-term vision. Can we reach that today? Probably not. Also from a manufacturing process standpoint. Is it a vision? Yes, and let's take that as a kind of vision. That's my take there.
Well said, Paolo. Feet on the ground and head in the clouds. Huh? Anyway, valid points though. Michael, what do you have to say? Do you have anything to add to Paolo's response?
Yeah, I would like to add something from my end. So in general, some of our audience might know that for a large cast aluminum alloy part, they typically suffer from a defect related to hot tearing due to the relatively high thermal expansion and volumetric difference associated with during the cooling process. If some of you read a story about Tesla's success on single-piece rear underbody on its Model Y, you could know that a famous material expert once helped Tesla to develop and then patented an unique aluminum alloy, which could allow a big bend angle with high material section thickness. This unique material attacks almost all aforementioned defects while simultaneously adding strength to the final parts. So therefore, material to me is vital to make megacasting work. And the material could possibly be the road blocker to cast an even larger single piece, as you just now asked, just Megacast 1, maximum 2. This kind of larger single piece material is quite important. Moreover, we have to bear in mind that functional requirement for a front, middle, and rear section of a car body could be totally different. These requirements are not only for strength, ductility, rigidity, but also something very special like controllable deformation, which could help to transfer the load or absorb energy during the collision events. It definitely would double or triple the difficulties to set up proper performance in different sections of the single piece car body made from even bigger megacasting process. So this is quite complicated to me. So this will in turn drive the design too complicated and the investment too expensive to accept. So I totally agree with what just now Paula mentioned. We need to be realistic on this matter.
Right. Now, one other question that I think is important to ask is about the potential applications of megacasting. Michael, can you shed some light on where this technique is viable, both today and in the future?
Thanks, Pranav. Thanks for the great question. And I could continue to make some extension to my answers to your last question. So basically, again, I would say we know that applicability of megacasting should largely depend on the functionality of the parts and whether megacasting develops part attributes that are good and complementary to the parts function. So all casting parts naturally and inherently have a higher static stiffness than stamped and joined ones. So this is some benefit. It has been prioritized towards the production of body structure in the car, especially for the body structure and the underbody. So let me be a little bit more straightforward here. It makes more sense to me to adopt a solution in the future, which is to produce separate sections through megacasting and then assemble them together. If we split the underbody into front, middle, and rear to megacast each of them, for example, to megacast the middle section of the car body, would be more possible than front section to follow the existing rear section megacast, especially for a pure electrified vehicle, which require additional considerations to the integration of the battery pack. Megacast could be and is likely to be helpful to save weight and protect the battery pack from side collision. As to the front underbody, because of the strict energy absorption requirement, I believe it favors the use of the wrought aluminum instead of the cast aluminum. So I believe it is less possible to megacast the front end of the underbody. Furthermore, I think sedans might have more opportunity here than larger SUVs because we know that for SUVs require a higher amount of metals to be injected through the custom machine due to the consideration of the finer parts properties and the performance. This might cause some actual increase in vehicle's gross weight, which is harmful to fulfill the target for weight saving. Lastly, I would like to mention that body frame, the body structure that is designed with megacast could only accommodate variations to the wheelbase or upper body design. It is not easy technically and financially speaking to support a highly variable products mix within a single plant. So in a nutshell, I'm thinking it is hopeful and possible to have the megacasting to penetrate the middle underbody section manufacturing in the near term. So back to you, Prina.
Understood. But let me just go back just a second to what was said earlier regarding the financial aspects of megacasting. Could you elaborate a little more on that, Paolo?
Yeah, sure. So of course, first of all, I think that we need to highlight that when we are talking about megacasting at the moment, we are talking about aluminum, right? And so we need to do a good comparison, an apple to apple kind of comparison here, right? So we need to analyze vehicle with body structure made in aluminum, but manufactured with the traditional, stamping, joining technique, with vehicles, manufactured with high pressure die casting, right? With gigacastings, right? So now in S&P Global Mobility, we have kind of run an analysis, right, an assessment, and comparing both the fixed and variable cost associated with the traditional manufacturing process on one side, with aluminum body structure, with the high pressure die casting on the other side, right? And this is to, again, analyze the feasibility of such manufacturing process, right? For such new manufacturing process. And what we have come out with is that despite having a higher upfront fixed cost, right? And I'm talking about high pressure die casting here, because of course there are investments needed upfront to retool, let's say, or let's say the manufacturing plant, right? From the variable cost perspective, instead, megacasting offers a very interesting and important cost reduction, right? Basically, the conclusion of all this top-level analysis that we have performed back in a few months ago is the fact that megacasting brings a potential cost reduction of almost 46%. With respect to the traditional manufacturing method, when you are talking about overall variable costs there, right? So that's the conclusion that we have came out with, which I think it's very important to stress the fact that this could be a very viable, let's say, manufacturing process for some specific OEMs in the industry, let's say.
Yeah, that's pretty strong analysis. I like it. Michael, we'd like to hear your 2 cents on the fixed investments that are needed to perform this switch.
Okay. When we would like to go deep dive the fixed investment, I think it is better to kind of discuss separately for different manufacturing type, as previously addressed by Paulo just now. One is what we define the brownfield type, which means to retrofit the plant floor to accommodate the set of the new megacasting equipment, and possibly discard the conventional tool sets for stamping and welding. So we need to consider the depreciated value of the existing manufacturing line. But for the another manufacturing type, we call a greenfield type, since it is totally new capacity is built up for new vehicle models in order to embrace mega casting. Could potentially lower space requirements, and in turn reducing the land lease cost. According to the research on manufacturing of aluminum car body we did before, we understood that the current market price for kind of 6,000 metric ton high pressure die casting machine, alongside necessary auxiliary device, could be approximate $6 million US dollar per set. Then if we add up the die casting tooling cost through the life cycle of a single vehicle model, which we presume as 100,000 piece here, total investment cost on plant floor, I would say, would range between 7.2 to 7.5 million US dollar. This number is roughly $4 million US dollar more than the amortized investment on the same amount of parts manufactured from conventional stamping and joining process. But as pointed out by Paulo earlier, great benefit of variable cost is hoped to be harvested from megacasting. So we could say the additional fixed investment will pay off for sure in some suitable scenarios. So that's my point.
Those are definitely some good and interesting insights. Now, based on both of your collective experience, do you think that megacasting can benefit all OEMs, or do you see any entry barriers or speed bumps? Let's start with you on this one, Paulo.
Yeah, no, it's very good question there, Pranav. I think that definitely, I mean, it's not a one size fits all kind of solution, not at the moment, at least, I would say. And I mean, I would like to make a couple of points here, right? So one is, generally speaking, again, we need to analyze the landscape here. So in the current automotive OEM market, let's say, there are traditional, let's say, steel intensive kind of OEMs, right, which basically produce and manufactures their cars and their vehicles with just some aluminum or let's say non-steel, let's call it like that, non-steel parts in it, right? And of course, for this category of OEMs, jumping into high pressure die casting means a kind of two-way jump, right? Meaning that it first requires to switch into aluminum kind of manufacturing process, which of course is pretty different from treating steel, right? And on the other side, there is the adoption of a new manufacturing technique, right, with high pressure die casting, which of course it's not, completely different from a manufacturing process, but still you need some time to adjust, right? So that's the difficulty there, right? And of course, on the other side of the spectrum here, you have aluminum intensive OEMs, right? So we can think about, guys like Audi, we can think about guys like Land Rover, Jaguar JLR, and things like that, right? And of course, they have been already using aluminum extensively in their structures, in their body structures, and so they are already used to, treating the material in a certain way. Of course, in this case is just one kind of jump, right? Meaning jumping into the new manufacturing process, right? Into high pressure die casting, right? And here is, I guess, my second point that comes in, right? Which is answering, I guess, to your question regarding the barrier to entry or to adopt this megacasting technique, right? Which is there is a somewhat skepticism, let's say, from some OEMs in adopting this technology, right? And the reason why there is this skepticism, I think, it comes from the fact that some of these OEMs have the kind of approach or attitude of saying, we have always been doing this in a traditional way, results are satisfactory, right? Why should we change, right? And I think that that's human nature, let's say, in a certain sense. Resistance to change has always been there and will always be there, right? In all humans, right? But at the same time, I think that there is also a skepticism from the OEMs because of the large investment that needs to be done first and foremost, but also the large investment in terms of human capital, right? Meaning there is a new competence that needs to be acquired, and so you need to have a workforce that is trained on this, right? Meaning you need to invest on people, and you need to invest on a mental switch from the engineers and the plant personnel to adopt this new manufacturing process, right? And I guess that this is one of the important barrier that needs to be overcome if we really want to see, OEMs adopting at a larger scale aluminum high pressure die castings, right, and mega casting generally speaking across the board. And of course, this is something that takes time, inevitably. But there are signals that things are slowly changing. Of course, also thanks to the push of let's say the dreamers, like we are saying before, like for example Tesla. So that's my general understanding of the issue here.
Absolutely, very well said. Michael, would you care to pitch in here?
Yeah, I would like to go straightforward to my conclusion here. I do not believe megacasting can benefit all types of OEM for sure, except something I have already touched in fixed investment analysis for brownfield type or greenfield type. I would like to add one more point from a part design perspective, which is to say megacasting generally require a brand new final part design, and it urged OEM to refine almost all intermediate process to manufacture a part. Therefore, this brings huge challenges and uncertainties to OEMs. They have to for some giant OEM like Volkswagen, like Fiat, they have to repeat the learning process and accumulate know-how from new mistakes and defeats they might undergo. Previously, OEM designers can iteratively optimize the final assembly by using different materials in the different parts, compromised within it. But using a single material and single gauge for large body subassembly, like what we are discussing now, megacasting, reduce the flexibility that allows part optimization in successive iterations. Secondly, I would like to say megacasting by its nature is unable to handle volatilities associated with changes in demand volume. This is very important, I believe. While a traditional line can simply handle kind of situation by increasing the number of robots at a single joining station, or kind of adjust the automated assembly process to reduce the cycle time to increase the volume. But on the contrary, any increase to the production volume of a megacasting line would probably require to purchase a completely new high pressure die casting unit, which is a considerably more expensive proportion. And last point from my end, it's about raw material price, because what we are now discussing is aluminum car body manufacturing. So aluminum price is a very dynamic market variables in these years. The financial feasibilities of the megacasting largely hinge upon the long-term stability of the aluminum alloy prices. And recently we know that geopolitical tensions have already caused manufacturers to consider different steel material instead of aluminum as alternatives that can provide similar degrees of weight reduction and improvement at lower price points and stable prospects in the future. That's my point. Back to you, Pranav.
Excellent. And before we wrap up today's episode, it would certainly be interesting to know what both of you think that the future of megacasting is likely to be. Are we all going to be living Elon Musk's dream, Paolo?
Well, I mean, definitely it doesn't hurt to dream, right? But again, as I was saying before, right, for sure, for specific segments, vehicle types, the possibility of seeing more and more megacasting coming in as a kind of new and alternative way of manufacturing body structure is a reality, right? But at the same time, we need to be very aware of that set of barriers that we have spoken about just before, right? And I think that I don't want again to repeat myself, right? I personally see a lot of opportunities here, right? In the sense that bearing in mind that still we have a lot of fixed investment to be done, but for example, I mean, if I put myself in the shoes of a traditional steel OEM, steel intensive OEM, I mean, I could see this as a big opportunity to really kind of change my game, right? And of course, it won't be easy. Of course, it won't be smooth, right? Because otherwise, it would have been very easy to switch. But at the same time, I think that if a traditional OEM would be willing to do that mental switch, right? And also provided that it will have the financial possibilities, right, to do those kind of investment, I see a lot of opportunities there. Of course, now I'm not here suggesting the fact that tomorrow we will see a segment car being done all of a sudden all in aluminum megacasting, right? Because that would be not economically feasible, right? Also from a end user's price point perspective, let's say. But definitely there is a lot of room for exploiting these opportunities from both the traditional steel intensive OEMs, but also the aluminum intensive OEMs, which who can really benefit of just switching their plants and retooling them with high pressure die casting kind of giga presses, right? So I think that the dream is still there from Musk, and hopefully we will be living this dream for sure. And I think that it's pretty easy to see this. Whenever Musk says something, it will take, I don't know how much time, but he will get there, right? So I'm sure that we will see more and more announcement on this topic from Tesla, let's say. And then hopefully, or not hopefully, but let's say, depending on the market situation, I'm sure that other OEMs will follow the situation there and will start adopting this manufacturing process.
Absolutely. I couldn't agree with you more. Michael, your closing remarks, please.
Okay, thanks for the question about the future, and I would like to provide some observation from China, because maybe we know that China OEM like Xiaopeng, like Leo, these new startups are keen and desirable to embrace this new mega casting manufacturing approach. And I believe that according to my understanding and observation, these OEMs will be more focused to seek huge benefits in turn from reduced variable cost from the mega casting process. So we are about to see in this race lane more innovative techniques which drive up the operation efficiency of individual mega casting machine to a higher allowable limit in the coming years to make these a new startup OEM can earn money to get a concrete benefit from this new process. On the other hand, megacasting has the potential to offer innovative opportunities to improve the flexibility of traditional vehicle supply chain. This is also some observation and some practice already start in China. The increased interest in megacasting technology in China now is expected to initiate the creation of a tier one supplier market, which is to say featured with suppliers that can absorb the high investment costs of die casting equipment and provide OEMs with no capital prefabricated parts on a per unit basis, ready to assembly. So it is promising, and we are looking forward to hear more news and more announcement about megacasting in this market and worldwide. Thank you. That's my closing remark.
All right. Thanks a bunch. And that's all we have time for today. Thank you to both of you for joining me on this podcast.
Thanks to you, Pranav. Thanks for having us.
Thank you very much.
And a big thank you to all our listeners for tuning in. We'd love to hear from you about today's episode. So do please send in your thoughts via email at autology@spglobal.com. And you can find much more at autotechinsight.ihsmarket.com. Don't forget to hit the subscribe, follow, and like buttons to stay on track with the latest Autology podcasts. And we look forward to you joining us again for the next episode. Bye for now.